All right, Chapter 6, multi-area OSPF. You know, after they give you single, they're going to give you multi-area. Now, multi-area OSPF is a heavy CCNP topic, but the new CCNA adds parts of it to its question base. So you are going to have to be able to answer questions on this on the new CCNA. I hate when my button doesn't work. All right, so we're going to talk about what multi-area OSPF is, how to configure it, and then we're done. So blah, blah, blah. If you want to read those, hit pause. If not, moving on. So multi-area OSPF. So remember, with OSPF, we have the routing table has information on all the different stuff out there. Remember, the DR, everything comes to the DR, and then the designated router decides how to get to different places. So if you've got a ton of routers, your table is going to be huge. So as businesses grow, they need to change or add multiple areas and start breaking up OSPF. Otherwise, your routing tables get so big. And remember, with OSPF, route summarization is not enabled by default. So they could theoretically be even bigger. So you get the idea. So that's where we need to do multi-area OSPF. And all we're saying is now, instead of just area 0, we're going to have other areas as well. So with multi-area OSPF, basically you always start with area 0. Area 0 is your backbone, and then the other areas need to connect to area 0. Now, when you get into CCNP, we'll talk about ways to get around that. But as far as CCNA goes, all other areas have to connect to area 0. So area 0 is your backbone. That's the one you create first, and then you can create the other areas. So when we're talking about these areas, normally we think, okay, this router's in this area, this router's in this area. But with this, it's not really like that. Now your router can be a part of 2 different areas. So looking here in this example at R1. You know, R1 has an interface that's a part of area 1 and an interface that's a part of area 0. So theoretically, he's in 2 areas, so he's going to be getting information from 2 different areas. So, you know, area 0 is your backbone area. And then you have your regular non-backbone areas that connect to users and resources. So I guess it all really depends on what you want to do. Some places, their main area is area 0, and that's where they put the servers. In other places, they have servers that go by department. So the finance server is in the finance department, and it's in that area with the finance stuff. So it all depends. There's a lot of material written about network design. And since every network's different, really, you have to kind of look at your stuff and think, you know, what would be the best way to do it in my situation? Because no 2 businesses are the same. No 2 businesses really have the same exact network. So as far as our class goes, your backbone area is focused on fast, efficient movement. How do I connect the other areas all together? So he's like the connector piece, or that the roundhouse for a railroad. And then all the other areas are the non-backbone areas, connect users and resources together. All right, now, lots of weird types of routers when we're talking about multi-area. So obviously the first type is internal routers. So in this case, area 1, these would be the internal routers. In area 0, these 2 would be the internal routers. In area 51, you have these internal routers. So an internal router only has interfaces in one area. All right, and then you've got your backbone routers. Now, why are these? Remember, all area 0 is considered the backbone. So anybody here in area 0 is considered a backbone. Then you have your ABRs, your area border routers. Any router with interfaces in more than one area is an area border router. So in this case, it's just R1 and R2. And then they have autonomous system boundary router, so ASRBs. Now an ASRB connects to multiple areas, just like an ABR. I always get these names all screwed up. But they also connect to a different type of network, like BGP, EIGRP, or some other system other than OSPF. So in this case, this is your service provider. Let's say your service provider is running BGP. So R1 connects to BGP and OSPF. So now he's an autonomous system boundary router. He's connecting between multiple systems. So that's the big difference between an area border router that just has multiple areas and an autonomous system boundary router. He connects to multiple areas and possibly some other system out there. So that's how I've always remembered that is, if the word system is in there, he connects to another system other than OSPF. Now that would have made it much easier if it was autonomous protocol boundary system than when it was another different routing protocol. But you get the idea. Now, depending on the role of the router, he'll generate different LSA types. Now remember, LSA stands for link state advertisements. So we've got a bunch of different types. Remember, an ABR may generate a different LSA than, let's say, your regular router that's an internal router. So luckily for our purposes, we're only going to cover the first 5, which are actually pretty easy. So let's talk about those. So the first one is the router LSA. So in the router LSA, when your router first turns on, he knows what's directly connected to him. Hey, these are my directly connected networks. So I only want to advertise my directly connected networks. So that's a type 1 LSA. And remember, if you use Wireshark, you can actually see these LSAs and then you can actually see the type number show up. Now, I haven't taken the new CCNA exam since it just changed in January, but I have taken the newest CCNP, and obviously these link state types and messages were very prominent on there. Like I had 3 or 4 questions on just those. So make sure you have a good understanding of these first 5 types. All right, so again, the link state type 1 is generated by all routers. And they're all saying, hey, these are the areas I'm connected to. So that's like their regular advertisements. Think of the LSA type 1 as your regular OSPF advertisements. So everybody has to generate those. All right, and then your type 2, remember, after the DR is elected, all your routers then, or all the DR others, send information to the designated router. So that's a type 2 message. So the DR then generates the type 2 message to go to all the other guys. So everybody sends something to the DR, remember, on 224.0.0.6, and then the DR says, hey, I'm going to send out this new type 2 message on 224.0.0.5, and then that goes out to all the other routers. So your type 1 is generated by all routers, and then your type 2 is only generated by a designated router. So in this case, each area has a designated router, and then each area's designated router would generate a type 2 message. All right, now here's where it gets weird. So you have a type 3 message. The type 3 messages are the networks learned by your ABRs. So in this case, ABR1 is a part of 2 different networks. So he would create a network summary of Area 1 and send it over to Area 0. Area 2 is an ABR, and he has a summary of Area 2, and he would send it to Area 0. And then these guys would both take Area 0 and send it over to Area 1. So that's how the other areas find out information about the other areas they're attached to from Type 3 LSAs. So those are only done by ABRs. So Type 1 done by all routers, Type 2 by the DRs, Type 3 by the ABRs. And then Type 4 is used to advertise an ASBR to other areas. So your ABRs also generate a Type 4. So ABRs generate 3 and 4. So in this case, the ASBR here in Area 1 generates this Type 4 message, and then he sends it to, he's the ASBR. He generates the message and he sends it to the ABR. Then ABR sends it to Area 0, and then this area ABR gets it, then he sends it to Area 2. So ASBRs typically will create those messages and then forward them, and then they're propagated through the ABRs. And then you have your final type, your Type 5, and this is where the ASBR generates based on the networks that he knows from these external sources, remember the other systems that he deals with, and then he sends that internally. So it's kind of like a Type 3 message sent from an ASBR. Remember, an ABR sends a Type 3 message about the networks in other areas. Then an ASRB sends a Type 5 message that generates the network addresses from different systems. So I hope that helps. If not, I've included a link in your folder. Jeremy Sior, and I always mess up his name, talks about these areas a lot better. I'm sorry, these types a lot better than I do. So I included a link in your folder. He's got a micro nugget. It's only like 5 or 6 minutes long, where he digs into these. And again, if you are planning on taking the new CCNA, these types are featured, so make sure you understand them. Because you'll see a question like, well, they'll show you networks, and they'll say, hey, what kind of message would the ASRB generate? Well, the ASRB router would generate a type 5 message to let everybody know about the other networks that he knows about from other systems. All right, so luckily on the CCNA, you only need to know those first 5 types. Whew. All right, and then if you go in your routing table will show you what types of networks you know about. So remember, O is for OSPF, and that's your internal OSPF networks, OSPF networks in your area. And then IA is for inter-area OSPF. So down here where you see these IA routes, those are from other areas reporting to you. And then if you see E1 or E2, like up here, now we're talking about external LSA types. All right, so it shows up the same way in version 3. Remember with IP6, they show up as E or I, internal, external. And then remember, all OSPF routers will send a message to the DR about their directly connected networks. And then the DR will look at it from his point of view, and then he'll minimize those and pick the best path to each network, and then send it out to everybody else. And then your routing table is converged, and everything starts working. All right, configuring multi-area OSPF. Obviously, you need to gather all your information. What networks am I going to advertise? Who's going to be in what? Blah, blah, blah. And then I need to configure OSPF and then verify. So in this case, again, we have our 3 router. So router 2 is going to be our backbone area, so area 0. So all 3 of his interfaces are going to be in area 0. And then we're going to have 2 different extra areas off the bottom. Router 1 is going to have 2 interfaces in area 1, and router 3 is going to have 2 interfaces in area 2. So router 1 and router 3 are area border routers. They border multiple areas. And then R2 is just your regular area 0 in regular router, if that makes sense. So remember, router OSPF 10. So again, I'm on R1 down here. So I go to router OSPF 10. Remember, this is the process ID, which is locally significant, doesn't matter in OSPF. And then I create a router ID. Remember, the highest router ID becomes the DR. And then I create the network. So I say network, this network is going to be in area 1, this network is going to be in area 1, this network is going to be in area 0. So he's connected to 3 networks, 1, 2, 3. So he wants these 2 networks in area 1 and then this network in area 0. So it's as simple as that. Then you would do the same thing on the other routers. Now remember, with IP6, it's a little bit different. With IP6, we turn on OSPF, so IPv6 router OSPF 101, set the router ID, and then we go to the specific interfaces and turn on the areas. So in this case, both of those are on this one physical interface. Let me go back here. Those are weird. I have no idea where they're going. But anyway, so apparently in this example, they only have one interface going into area 0, or area 1. So then he's area 1, then this interface is area 0. But remember, you assign those you go to the interfaces and assign the areas. Where with version 4, or IP version 4, you assign them through the network statements. All right, now don't forget, by default, OSPF doesn't summarize your routes. You got to turn that on. But with OSPF and multi-area, it summarizes at the borders. We want to try to summarize between areas. So that happens automatically. So let's talk about how these different LSA types kind of go through. So the type 3, remember, R1 is in 2 different areas. So he has IP information for 2 different areas. So he creates an LSA type 3 message for the network information from area 1, and he sends it to the backbone area. And then the backbone area sends it to R2 and R3, then R2 and R3 send it to their internal routers. So that way, everybody in area 2 and area 3 know that the network exists in area 1. So remember, the way I've always understood it is that the type 1 is all routers, so all routers advertising their directly connected networks. Type 2 is from the DR sending information to his internal routers. And then type 3 is your BRs, and that's them advertising the network information to the other routers. And then type 5 is your autonomous system border routers advertising network information from different systems. So type 1, 2, 3, and 5 all make sense to me. Type 4 has always been kind of weird. So we summarize that information between areas because there's no reason that R2 here needs to know that 10.110 and 10.12. He doesn't need to have routes to both of those. He just needs to have a summary route. 10.1 go to R1, and then R1 would handle the difference between 10.11 and 10.12. So we summarize automatically at area border routers. So you can see in this slide, here when R1 sends his stuff, because he's an area border router, he's going to summarize the information he sends. So he just sends 10.1, 00/22, because that matches all networks inside area 1. So that's all he needs to do to send it to R2. So that way R2 doesn't have to have multiple different routes going to R1. All right, then of course, after you set it up, you have to verify. So we verify show IP route OSPF, begin gateway, and that skips your the legend. And we can go check and say, hey, I am getting stuff from other inter areas. Remember, an inter area is one that's connected directly to you, and then an external area may not be directly connected to you. And we'll talk about that when you get to the CCNP classes. All right, then the chapter goes on and talks a lot about route summarization and how to summarize. Now, we've already covered this in class, and you've had it in routing and switching, and we've already talked about it before last section. About how to summarize routes. Remember, if you have route that 192.168.100, 192.168.101, 192.168.102, you have to find how many bits match, and then you just change the subnet mask to match that. So if for some reason you totally forgot about route summarization, bring it up in class, and I'll cover this again in class real quick. All right, so again, they show you how it's summarized, and they just change the subnet mask to /22. All right, verifying. Show IP OSPF neighbor to see what neighbors am I in. Show IP OSPF. That's always my go-to because it kind of, I'm sorry, I do show IP protocols. Show IP protocols. I'm so confused. That's always my go-to because it'll show me I'm running OSPF, what networks I'm advertising, things like that. But if you're doing OSPF version 3, which is IPv6, sometimes show IP OSPF interface is better because it shows you what interfaces have been configured for OSPF. So those are your two big ones, show IP protocol, show IP OSPF interface. All right, so again, here's what they look like. The show IP OSPF interface brief just shows you the interfaces that are running OSPF. Then it kind of gives you the little summary thing. But then there's my bread and butter show IP protocols. Shows me I'm running OSPF for area 10. Shows me my router ID, number of areas this router's in 2, and then I'm advertising 2 in area 1 and 1 in area 0. My neighbors, that kind of stuff. So usually this will answer most of my questions. All right, then you can check the routing table to verify your route. Show IP OSPF gateway. Or show IP route OSPF / begin gateway. Remember, that just skips the legend at the start. And you can say, hey, I am getting updates from interconnected areas, so I'm good. I can also do show IP OSPF database. Now, I don't really use this typically, this command, and I haven't really had a lot of use for it, but it's there. So this shows you like the link state database. What networks do I know about? How do I get there? That kind of information. All right, then as you're verifying, it's the same way in version 3. You just show IPv6 protocols, and you'll see what interfaces are participating. Show IPv6 route OSPF will show you the different routes, and say I see an I, so I'm getting information from other networks. All right, show me the database, that kind of stuff. So everything's the same with IP4 or IP6. It's just you got to put the v6 in front if you want to see the IPv6 stuff. So that's really it. Kind of a short chapter. Again, you've already had the 45-minute OSPF lecture. Now we just had to deal with, how do I do multi-area OSPFs? And the big thing on the exam, it's not really the configuration, because that's easy. I mean, you just put the different interfaces in different areas. That's the only difference. But they do test on those LSA types, which is a pain in the butt. Now, again, in the real world, when you're working on big networks that are all interconnected like that, knowing those LSA types and being able to view those to find problems, obviously is an important skill. But that's not one you're going to get at a 2-year college. That's something that you've worked on with other technicians in the field, where you've learned those networks and you use their tools, and you've been there for several years. You're not going to graduate a 2-year college and they're going to send you into some big network and say, oh, hey, you're here with AT&T, and I want you to troubleshoot the whole Eastern Seaboard, the OSPF problems. It just doesn't make sense, and it doesn't happen in the real world. So as far as the class goes, don't focus on those too much. I will be asking you, obviously, a couple questions on the exam about those. But in the real world, they kind of grow you into that. They have tools to look at that stuff. So I don't want you to focus too much on that stuff, I guess is what I'm trying to say. All right, make sure you know the difference between the different routers. Internal routers are only a part of one area. So yeah, one area. And then a backbone router is any router that's in area 0. Then an ABR is an area border router, and he is in part of 2 or more areas in OSPF. Then an autonomous system border router is in 2 or more areas and some different system, like BGP, EIGRP, or something else. Typically, it's your internet provider. Although sometimes, depending on what happens, like if one company merges with another company, their EIGRP and your OSPF, you'll have an autonomous system border router. All right, and make sure you understand that when the type 3 and the type 5 network messages, those LSA types, propagate throughout the different areas, they summarize the networks as much as they can so that they're not advertising more networks than they have to. And that happens by default. Remember, in OSPF, by default, we don't summarize. But anytime we're going between ABRs or ASBRs, we do summarize the advertisements to keep them as small as possible. All right, and then remember your LSA types. LSA1, generated by all routers. They're directly connected networks. LSA type 2, these are the messages from the DR telling everybody else, hey, here's what you're going to have in your tables. LSA type 3 is, hey, here's the networks that I know about between my 2 areas. LSA type 4 is, hey, here's information because I have an ASBR in my area, so I've got some extra information I need to share. And then LSA type 5 is the network information generated from the ASBR about the other systems that he knows about. So I hope that makes it clear as mud. If not, remember there's that 5-minute video from Jeremy Ciora, who does it very well, way better than I do on this stuff. All right, and then again, how to configure your stuff at just area 1 or area 0, whatever the interface is going to be in. Don't forget your how to verify commands. Remember, executing without verifying that stuff is working is terrible. You don't want to be that guy. I had a lot of network techs over the years, well, actually PC guys over the years, who I would send to go work on a printer. Hey, Internal Medicine's calling there, said their printer doesn't work, run up there and go fix it for them. And they would go up there and fix it, and then before they even came back, that person would call again and say, hey, Joe Bob just came up here. He thought he fixed the printer, but it doesn't work. Because what Joe Bob did was he went up to the printer, for some reason it didn't work or something, he jiggled a cable and then all of a sudden it worked and he left. He never went to the user and verified that they could still print. He may have fixed an issue on the printer because somebody had a jam in there, but he didn't fix the issue where the user had the wrong IP address in there, so she couldn't print anyways, if that makes sense. So you always want to verify things, make sure they work. Ray, then Cisco. All right, so again, if you have any questions, make sure you bring them up in class. As far as the exam goes, make sure you know, obviously the hands-on is going to have multi-area OSPF. I guarantee you the hands-on is going to have multi-area. But it'll probably just be 3 routers, and then there'll be 3 different areas. I don't think they're going to throw in an autonomous system border router on you. And there will be questions on the area type, so make sure you're good for that.